When it runs out of fuel, the star collapses and then explodes with the brightness of 1 billion suns.
Betelgeuse, located in the constellation Orion, stands out as one of the most easily recognizable stars in the night sky. You might have seen it yourself, as it's easily visible to the naked eye. Its striking red color and prominent location have captured the fascination of both amateur stargazers and professional astronomers. However, what truly sets Betelgeuse apart is its enigmatic nature.
We think it has to be at least 8 times more massive than our sun.
Astronomers refer to it as a variable star due to its pulsating behavior, constantly expanding and contracting in size. As a result, the star's brightness undergoes fluctuations, ranging from being one of the brightest stars in the sky to significantly dimming at other times. But now scientists have discovered something strange, and they say it's something to be concerned about. So let's find out what's happening. Betelgeuse is gigantic. It's more than 1,000 times bigger than our sun. Can you imagine that? If we put Betelgeuse right at the center of our solar system, it would swallow up all the inner planets, even Earth, and stretch all the way to Jupiter. And guess what? It's also a red supergiant, which means it's nearing the end of its life. But here's the thing. Betelgeuse's impending death is not what's got everyone excited. Stars die all the time, you know. What really caught astronomers' attention was when Betelgeuse started to dim. In late 2019 and early 2020, something extraordinary happened. Betelgeuse went through a massive dimming event known as the Great Dimming and lost a significant portion of its brightness. Since the beginning of this year, though, it has brightened up again by more than 50% compared to its usual luminosity. But here's the kicker. The star has suddenly stopped pulsating on its usual 420-day cycle. And that's pretty mind-blowing, considering it's been sticking to that pattern for centuries. That's what really got scientists scratching their heads and wondering what's going on. Scientists came up with all sorts of theories to explain Betelgeuse's dimming. One idea is that recent research suggests that Betelgeuse, nearing the end of its carbon supply, is on the verge of going supernova. Another idea stood out and was eventually confirmed by the Hubble Space Telescope. According to Hubble's data, it turns out that the star actually expelled a massive cloud of dust, which partially blocked its light from our view. It's like Betelgeuse decided to put on a little show for us. But did you know that Betelgeuse would take a whopping 1,000 years to fuse carbon into heavier elements in its core? Figuring out exactly how much carbon remains in its core at this stage is quite a challenge. However, scientists have made some fascinating discoveries by studying the pulsations and brightness of Betelgeuse. They found that only a small fraction of carbon, between 0.48% to 17%, is left in its core. That means Betelgeuse has already consumed a significant portion of its carbon and is rapidly approaching the supernova stage, which could happen in just a few decades from our perspective. In fact, it's possible that the explosion has already occurred in real time. But when will this epic event actually happen? Well, nobody knows for sure. Except for a team of scientists, that is. The reason why everyone is so excited about Betelgeuse's supernova is because it will be an absolutely mind-blowing spectacle. When Betelgeuse finally goes kaboom in our frame of reference, its brightness will surge dramatically, potentially outshining the moon and even becoming visible during daylight. And believe it or not, according to those scientists, the explosion may be underway right at this very moment, or could be just around the corner in the near future. An amazing new study has recently revealed that we have seriously underestimated the size of Betelgeuse and its timeline for evolution. Based on the latest observations, researchers now suggest that Betelgeuse could explode within a few tens of years, rather than hundreds of thousands of years as previously thought. If astronomers were to make bets on the next nearby star in the Milky Way to go supernova, Betelgeuse would likely be a top contender. This bright red supergiant star, located on Orion's shoulder, is approaching the end of its life, and it's positioned less than 1,000 light-years away from Earth. But the burning question remains: how close is Betelgeuse to the supernova stage, and will we be lucky enough to witness it? Despite the immense energy released during a supernova, we can rest assured that the significant distance between Betelgeuse and Earth will shield our planet from any harmful effects caused by the explosion. Typically, astronomers have speculated that Betelgeuse might explode within the next 100,000 years, which is relatively soon on a cosmic timescale, but not exactly within our human lifetime. By studying its pulsations, astronomers have come to the realization that we were mistaken in our calculations regarding the size and timeline of Betelgeuse's evolution. However, it's worth noting that our estimates may have been off, and the astonishing spectacle of its supernova could unfold before our very eyes at any moment. According to a new study conducted by Hideyuki Sayo and his colleagues at Tohoku University in Japan, it's possible that Betelgeuse is further along in its evolution and much closer to exploding than previously believed. How do they make this claim, you ask? Well, it all boils down to the star's pulsations, which provide valuable insights into its current state. You see, Betelgeuse is a very interesting star. It's actually quite unstable, almost like it's breathing in and out regularly with overlapping rhythms. Astronomers have been studying its brightness for the past century, and they've noticed some changes occurring over different periods of time. They've observed cycles of 2,200 days, 420 days, 230 days, and 185 days. Typically, astronomers consider the 420-day cycle as the main pulsation, kind of like the star's primary in and out movement, with the shorter cycles acting as secondary patterns. The 2,200-day cycle, on the other hand, is seen as a longer secondary period, something that's common in about 1/3 of supergiant stars, but not directly related to the main pulsations. It's still a bit of a mystery where this longer cycle comes from. If we consider the 420-day period as the primary one, then Betelgeuse would be the equivalent of having 800 to 900 suns lined up in a row. That's massive. However, Sayo and his colleagues think that this estimate might be too conservative. In their research paper, they present evidence suggesting that the 2,200-day cycle is actually the fundamental mode, with the other 3 cycles acting as overtones. If the 2,200-day cycle is indeed the primary one, and the others are just overtones, then Betelgeuse would be even more gigantic, spanning the size of 1,200 suns. That's even wider than Jupiter's orbit, and with its larger size, the star would be further along in its life cycle. Stars like Betelgeuse live fast and large. Similar to the Sun, they begin by fusing hydrogen into helium in their cores, but they quickly move on to helium fusion, producing carbon. This carbon then burns to create even heavier elements. As this process happens, lighter elements burn in shells around the core, causing the star to expand outward like a hot plasma balloon. Sayo and his colleagues use computer simulations to observe the evolution of stars from birth to old age. They calculate the pulsations that should occur at each stage. What they've found is that all 4 pulsations, from the 2,200-day cycle to the 185-day cycle, can be explained by a breathing star in the late stages of carbon burning. The researchers note that once the carbon is exhausted in the core, a core collapse leading to a supernova explosion is expected within a few tens of years. However, determining exactly when the carbon will run out is challenging because the pulsation periods don't change significantly at this late stage. Sayo explains, "It's not possible to precisely estimate how much carbon is left in the core at present. We can only speculate that the time until carbon exhaustion is probably less than a few hundred years." So, let me put things into perspective for you. Sayo's group is not saying that Betelgeuse will explode tomorrow or even within the next decade. After the supernova event, when the dazzling show is over, Betelgeuse's core will still be there, but it will have undergone significant changes. It could potentially become a neutron star or even a black hole. What the researchers are claiming is that Betelgeuse is likely to explode within the next 1,000 years, rather than waiting for 10,000 or 100,000 years. Now let's talk about the 2,200-day pulsation. If it's happening radially, it poses some additional problems. Spectroscopic measurements reveal that the star's surface expands and contracts at a rate of about 1.5 kilometers per second, 3,300 miles per hour. If this breathing pattern occurs over the span of 2,200 days, the star's diameter would change by 180 times the size of the Sun in each cycle. That's quite a significant change, even for astronomers. Moreover, This 2,200-day pulsation would also impact the pulsation of the overtones. For instance, the 420-day cycle wouldn't always remain 420 days. When the star expands to its maximum size, the overtone cycle would lengthen, and when it contracts, the cycle would shorten. However, the evidence does not suggest that these changes occur systematically within the 2,200-day cycle in Betelgeuse's long-term light curve. Instead, the variations appear to be more random around the typical 420-day cycle. Now, for those who may not be aware, when a star exhausts its hydrogen fuel, helium starts burning into carbon, which causes the star to swell. As the star runs out of all available fuel and the remaining elements cannot sustain fusion against their own weight, the core collapses, forming a dense neutron star. The surrounding gas rushes inward, rebounding against the core, resulting in a supernova. Betelgeuse, with an age of at least 8 million years, is believed to be in the final stages of its life cycle after burning through the hydrogen in its core. Now you might wonder if we'll be able to witness the Betelgeuse explosion. Well, if we somehow manage to live for another couple of thousand years, then yes, we might be able to witness that incredible spectacle. Just imagine how amazing it would be. Subscribe to Beyond Discovery and see you in the next episode.